Okay, so yeah, so now the chat seems to be working now. All right, so let me just test again. Yeah, it is working. Right, so the thing which I was trying to do in here was actually like, write a book regarding this computer science. And what I was looking for was the units which I have covered is like the 10 units in here. And the first one is like discrete structures and optimization, right? So this is the first topic, discrete structures and optimizations. Okay, so the discrete structures and optimization. So it starts with the mathematical logic. So this one is fine, and this one is fine. The mathematical logic provides the formal rules for valid reasoning. It is the bedrock of digital circuit design, automated theorem proving, database query languages, and artificial intelligence. Right. So that is this part is okay. This part is okay, even though many would falter and fall into their head reading this, but this is okay. Okay, and then propositional logic in depth. We have okay, so this one is what? This one is a proposition is a declarative sentence that possesses a definitive truth value. It is either exclusively true or exclusively false. Okay, right. So okay, so in here, so the one part in here, it is like so. So it does talk about the propositional logic, right? So it does talk about the propositional logic. Propositional logic it talks about. So a proposition is a declarative sentence that possesses a definite truth value. Not a definitive sentence, it's a declarative sentence in here. Right? So that is correct. So that is a declarative sentence. Okay. That is a declarative sentence, declares things, declarative sentence. Right. It is a declarative sentence that possesses a definitive truth value. It is either exclusively true or it is exclusively false. Right. It is exclusively true or it is exclusively false. Now we have this one. Okay. So it is a declarative sentence. So we can say that it is an equation as well. So let's say I have written something in here, like equivalence I have written in here. Right. Equivalence I have written in here, and right. So the first one is then I have jumped onto the logical connectives. Okay. So okay, this is a quite I've written this in a very concise manner in this one. So it's like I've just gone to the propositional logic in depth and just stated that what is a proposition. So proposition is your declarative sentence that possesses a definite truth value. It is either true or it is exclusively false. Okay. So that is very concise I have written in this one. And if someone tries to like, bend it towards some other purpose, then it won't make any sense if they want to do that. Right. So this is a very straightforward and concise way of saying this one. Right. Now next is your detailed logical connectives. Okay. The detailed logical connectives are like they basically what they do is that they join these propositions, two or more propositions, right? So at least they will join two propositions in this one, right? So that is what they do in this, right? So that being said, so we have what? We have P and not P in here. One in this, we have two things in here, P and not P. So this is a simple negation logical connective. So this one, okay. So in again, so this one, right. Okay, so I'm correcting myself again in this one. So propositional logic in that proposition is a declarative sentence that possesses a definite truth value. It is either exclusively true or exclusively false. That is correct. And then we have detailed logical connectives. Let P and Q be arbitrary propositions. Okay, so in here, we don't need two operands to make this, right? We don't need two operands to make this in the first place. So detailed logical connectives, let's P and B to arbitrary positions. Okay, let P and Q be two arbitrary propositions. Okay, I'm fumbling now again. Right. Let's try this again. Detailed logical connectives. Let P and Q be arbitrary propositions. Okay. Let P and Q be arbitrary propositions. Right. Okay. It doesn't require you to like have two operands in the first place, right? It doesn't require you to have two operands. So the proposition could be either one or two propositions. It could be there. So even one proposition could work, right? So even one proposition could work in this one. And this is see that is the case. So P will be not P. So true will be false and false will be true. This is the simple Boolean logic as well. So the both concepts coincides in this one. And then we have the conjunction. So we have the conjunction. Conjunction is P conjunction Q. It is a logical AND. So in case of binary logic or Boolean algebra, it is a logical AND. So we have if both of the propositions are true, then the resultant will be true. If either one of them is false, then it will be false. And if both are false, then it will also be false. Okay, so that is understood. Now the thing which is I'm missing in here is like disjunction. So disjunctions I have not written in this one. Okay, so I have to write disjunction. Okay, so what I have to do is I have to write a disjunction. So disjunction is not written. Let me see. Where I have kept a file now. Mm, disjunction. Mm. So for disjunction, it will be what? Do I have this in here? Open board, right? I have open board. Let me just close this one. Backgrounds, I will just take a black one. Right. So yeah, we only talk about disjunction. Disjunction would be okay. So let's say if you have E and it's a disjunction, like P and Q. This is there. So if this is true and this is false, this will give me what? Uh, let me make two more columns, right? This will be Q and will be P, right? So hmm, so we have, let's see, we have true in here and false in here. And then we have, so this is disjunction. So disjunction, we have disjunctions. We have what? We have true in here, and then in here we have false. Then we have true. Then we have, and here also we will have what? True, right? Here we also have true. Okay, and then there are two cases in which there will be what? The two cases there will be there will be this will be true, this will be true, and this will be true as well. Okay, and the final one will be uh, this will be false, this will be false, and this will be false. Right, so kind of like this. It is kind of like this. This scribble should be there. Okay. Uh, this scribble should be there. Hmm. So now the disjunction table is here. Okay. So true, 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 false, true, true, and false, false, false. Right. Then next is the exclusive or. If a truth, okay. True if exactly one operand is true, but not both. Equivalence is what? P XOR Q, which this implies what? P conjunction not Q, disjunction not P conjunction Q. Okay. So I think I should just include the table for XOR as well. exclusive or okay. So I should include that as well. So again, in this one, if you go back to the board, right, you go back to the board. So when we talk about XOR, right, when you talk about XOR, so XOR is okay. When we talk about XOR, then okay, so again we can create two things in here. We have P in here, Q in here, and then P. This will be XOR and Q. Right, so this is the scenario we have in here. Okay, and this is the scenario we have in here, and then okay, right. So see, in here, what happens is see, true if exactly one operand is true, but not both. Okay. So in here, if exactly one operand is true, then only it will be true, right? So then we go back to our board in here. So if we have, let's say, true in here, and we have false in here, then XOR will be true. Okay. Then let's say we have false in here, then we will have true in here, and we will have true in here. Then next what we have is suppose if both are true, right? If both are true, then this is true, this is true. In here we will get false because the exclusivity is in here, right? So since it is an exclusivity, right? So if both operands are same, if both operators are same, then it will be false. Okay. In the similar way, whether it is true or false, if both operands are same, then it will be false. Okay. So in case of false, it will obviously be false, right? So it will be obviously be false. Okay, so this is the scenario regarding this one. Okay, Mm, let's go back to desktop and refresh this one. Right. So as I said, it will be true, and then it will be false. Okay, true, true, and false. If it is true and false, then it will be true. It will be false and true, then it will be true. If both are false, then also it will be false. So that is the table it is represent in here one. Okay, implications. Implications. What are implications now? Logical conditional if P and Q. If P is the hypothesis antecedent, Q is the conclusion consequent. So antecedent will lead to consequent. It evaluates to false only when the hypothesis is true, but the conclusion is false. Right. So this we do as what? So if this P implies Q is inherently true regardless of Q. Okay. This one is the vacuous truth. Okay. So let me understand. Let me make you understand this one. Okay. Studied this before, but I'm just revising it for this study session. So let's go back to the board again. Okay. Uh, Let me erase this. Okay. So coming back to in here. Okay. Getting some weird notifications regarding weird things. All right. Okay, so first thing is the vacuous truth. Vacuous truth is what? Vacuous truth. If P is false, P implies Q is inherently true regardless of Q. Q is inherently true regardless of if P is false, P implies Q is inherently true regardless of Q. Okay, so whatever Q comes in this one, P will be true regardless, right? So I think we can understand like this. We can understand in this way. We can understand this in this way. So let's understand in this way. Suppose if we have some kind of a belief, right? Suppose if we have some kind of a belief. First common belief is you have a God. Right? So if you have a God, which is and you expect God to do something for you because that you pass some examination, whether it's CE, whether it is CCNet, some kind of exam. You think that if God is there, then I will pass the exam, right? But this, for this case, because we are talking about God anyway, this will be what? This will be a vacuous, right? This will be a vacuous. So what does that imply is that I remember I cannot write in this one anyway. So this is a vacuous. So let's write this as VT. Let's write it as VT. This is basically a vacuous. Okay. This is a vacuous, right? So what does that mean in here is that whether suppose Q is something that you graduate, right? Yeah, Q is something that yes, Q is something that you graduate. Okay, very difficult to control my heart. Anyway, Q is something that you graduate. You graduate because you believe that God is there, which is P. Okay. So it's like for Brahma or something, I think so P is there. You believe in this God, and you will graduate because God is there. Even if you don't graduate, even if this turns out to be false, okay, this turns out to be false, you failed in even then, he is still here, God is still here, right? So this is a kind of example of like uh, so if P is false, you understand this one correctly. That uh, can ever end. If P is false, with you, inherent with you, regardless of you. So let's see, P is false, plus you is inherent with you, regardless of you. speaking right now. And if it is wrong, that is yeah, I don't think okay. So right. So I may have to like give more explanation regarding this one because even I get confused in this one. Okay. So if P is false, P implies Q is inherited regardless of Q. So let me give a better explanation of this one. Okay. It's more like it's more like so we have some proposition. We have some proposition. So let's say the proposition is that sun rises from the west. So we have one proposition, which is that sun rises from the west, which we say as P. Okay. Now this is obviously this incident is not true. So the next person says that if sun rises from the west, then we have two moons or something. Like this will be Q. So if sun rises from the west, we have two moons. Again, since this incident is not satisfied, Q must be true regardless. This is how the logic is going. Because Q is dependent on the incident and incident which we cannot prove. Right. So this is the whatever conclusion we made in here, it is true regardless because we cannot prove the incident. So the consequent Consequent is true regardless because we cannot prove the incident. Okay, so the incident is cannot prove the incident itself, so the consequent is true regardless. Hmm. It's like it's one of the famous saying from one of the anime called Cowboy Bebop. It is like whatever happens happens. Right? No, I think Cowboy Bebop had this. I think it has that quote. Whatever happens happens. Either that or it had something like let it happen or something. Maybe I think it is whatever happens happens. So this this one, the vacuous truth is like that. Like so, it's like whatever happens happens. Right. It's yeah. So vacuous truth. It's more like whatever happens happens, or it is what it is. Right. There is one other thing. Like I think some Italian fellow used to say that it is what it is. Right. It is what it is. Right. So this happens. This happens because we cannot prove the incident itself. So like we cannot prove an incident. So obviously we cannot deny the consequent itself. Right. So yeah, finally I'm getting my brain cells back. Right. Finally I'm getting my brain cells back. So antecedent we cannot prove. So the consequent is true regardless. Okay. So let's see. So because this antecedent we cannot prove, so the consequent is true regardless. Right. So yeah. So this quote, like whatever happens, happens, or like it is what it is. These kind of quotes. That is the logical explanation of this one. Because we cannot prove antecedent in the first place. Right. So yeah. Right, so next is what? Mhm. Yeah, should fix my vocals as well. Okay, so next is what? Hmm. Next is converse. Not given any explanation regarding converse. Inverse I have given. Contrapositive. So Hmm. logic and mathematics, the converse of a categorical or implicational statement is the result of reversing of its two constituent statements. For implication, P implies Q, the converse is Q implies P for the categorical proposition. All S are P, then the converse is all P are S. Either way, the truth or the converse is generally independent from the original statement. Mm. Give some kind of, explanation regarding this one. Last, for explanations, for example, we get an hypothesis of what is it from the trigger to it was broken. If it is raining, then I will carry. On a sunny day, TV is false. The statement is accurate. So since it is not raining, the condition never applies, and the promise cannot be violated. So no matter what you what you why it matters. This is why mathematics. This is why in mathematics statements like all integers are greater than 5 and less than 3 are prime is accurately true. There are no such integers. The hypothesis is always false, making the implication trivially true. Like all integers are greater than 5 and lesson 2. More into this lesson 5 and lesson this example is like, again, I use that. Let's take a break. I should get it. But, uh, what is it that I want to get? Uh, Okay. So I've read these all these things in here, right? I've read all these things in here. So what I understood is like in mathematics, we have something called like I was trying to figure out this portion in here. Okay, I was trying to figure out this portion in here. So suppose you have P, which is antecedent, right? And antecedent is your, let's say, suppose the concept of God is in here, the par Brahma, concept of God, right? Concept of God is in here. So for theist, a God is there, right? For theist, a God is there. So again, for theist, the God is there. So I've written th as an indication of theist, right? So the God is there. Now, if the God is there, so he says that because of the God, because of the Parabrahma, I was saved from the accident, which is the consequent in here. Okay, so that is what they are implying. Now, when we go to, let's say, an atheist, okay, when we go to atheist, theist and atheist, when we go to atheist, okay, now, yes, atheist, right, theist and atheist. When you go to theist and atheist, when you talk about atheist, when you talk about atheist, talk about atheist. Atheist is what? For them, God is not there, right? So for them, God is not there. Since the God is not there for atheist, since the God is not there for atheist, when the theist, when the theist says that he was saved from the accident because of the God, logically it is trivially true because for atheist the God is not true, so the antecedent is not true, right? So the antecedent is not true. So obviously if the antecedent is not true, the consequent is obviously true regardless of, okay, so the consequent is always true, right? So the consequent is always true. Yeah. So the consequent is always true the because theist believes something which atheist doesn't believe. So whatever he's saying regarding the consequence, for atheists it is always true, right? For atheists it is always true because the antecedent which the theist is saying, that is not true for atheist. Okay, this kind of gives into the fact of like perception of truth is quite subjective. Yeah, I did talked about that as well, right? So, um, perception of truth is quite subjective. Uh, that is why empirical evidence is required in this one. Empirical evidence. Hmm. Hmm. Yes. Converse. Now let's go to converse. Okay, let's go to converse. Right, talking about converse, and we are talking about converse. So converse is what? In here, P implies Q, right? So if it is, let's let's clear the board. And, right, let's erase the board now. So now converse. When you talk about converse, right? When you talk about converse, more like P implies Q, right? P implies Q. This is like, so let's say, suppose there is one proposition that if it is raining, then the ground is wet, right? So, so ground being wet, okay. So if it is raining, then the ground is wet. That is the proposition in here, okay. So ground is wet and it is raining. Now, this also implies that the ground is wet. The ground is wet. Then there is it is not raining. However, this might not be entirely true. This might not be entirely true. Why do not entirely true? In some cases, true. Yes, some cases, some cases, proposition is true. So, this is for for second word. Okay. So, converse is true in some cases, and in those some cases, this proposition is true. Okay. Proposition is there's two things, biconditional relationships and converse relationships. So, when we talk about biconditional and and converse relationships, they get confused. They usually get confused. So, usually what people assume is that a converse relationship always uh, directs towards a bidirectional relationship. It's not the case, obviously. Right? There could be a third factor involved in this. There could be a third factor involved. So that is what we call like a correlation of things. But we'll get into that correlation kind of stuff later on. However, converse is bidirectional. The question to come is like, what is the difference between a converse relationship and a bidirectional relationship? Uh, what is the difference between converse and bidirectional? Right. I'm going to do one thing. I'm going to stop the screen right here and continue writing the next chapter of this next session.